In a remarkable declaration, scientists have proclaimed that they have discovered a celestial body unlike anything previously observed. NASA, renowned for its groundbreaking revelations, has revealed that this planet is intriguing not just because of its magnitude and location, but also due to the artificial nature of the illumination it emits. Are we nearing the disclosure of concealed realities that could profoundly transform how we understand the universe? Could this finding suggest the probability of alien life? By examining NASA's pioneering discoveries, we are on the path to unveiling the truth behind this extraordinary occurrence. In 2007, NASA initiated the Dawn expedition with the goal of investigating some of the most captivating objects within our solar vicinity. Equipped with 3 ion propulsion systems, Dawn began its journey with a 14-month investigation of Vesta, the second-largest object in the asteroid belt. It delivered exceptionally sharp images and comprehensive data, illuminating Vesta's intricate surface features and diverse geological history. After accomplishing its objectives at Vesta, Dawn advanced to the next phase of its mission, an even more exhilarating undertaking, an extensive study of the dwarf planet Ceres. Thanks to its ion-powered thrusters, Dawn escaped Vesta's orbit and navigated toward Ceres, a maneuver unattainable through traditional chemical propulsion techniques. These engines provided a consistent thrust, enabling the spacecraft to traverse vast distances and enter a stable orbit around Ceres. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest entity within the asteroid belt between Mars and Jupiter. For 4 years, it held the status of the smallest dwarf planet in our solar system until reclassification in 2006. With a diameter close to 950 kilometers, Ceres is the most sizable and massive object in the belt, distinguished by its unusual characteristics. Scientists eagerly awaited the first detailed images of this enigmatic world, which revealed dazzling spots peppered across its landscape, particularly inside a colossal impact crater known as Ader Crater. These brilliant patches instantly sparked interest and hypotheses among researchers. Before the Dawn mission, the most precise images of Ceres were blurry, low-resolution snapshots captured by the Hubble Space Telescope. Our knowledge of this dwarf planet was severely limited, and the prospect of high-definition observations excited scientists and space enthusiasts alike. Dawn's mission aimed to expand our comprehension of the solar system's formation and to examine the role water has played in molding planetary bodies. The bright features on Ceres, similar to those observed on other asteroids, might consist of highly reflective substances, possibly salt residues from evaporated water. This suggested the potential presence of cryovolcanism, where water or brine erupts instead of molten lava. But what precisely are these enigmatic lights, and what can they reveal about the true nature of Ceres? Are they evidence of active internal processes, or could they point to something even more astonishing? Ceres differs from most other objects in the asteroid belt due to its size, mass, composition, and potential water reserves. While typical asteroids are rocky, Ceres exhibits a more comet-like constitution, implying it might contain deeper clues about the early solar system. After 2 years of space travel, Dawn finally began approaching Ceres in early 2015, marking a critical moment as it prepared to deliver the most detailed perspective ever of the belt's largest resident. As Dawn drew nearer, its images became increasingly clear, exposing a previously hidden world. Early photographs revealed a cratered terrain recounting a long history filled with collisions. But what stood out most were the peculiar glowing regions embedded within the dark, rugged surface. As the resolution of the pictures improved, scientists started formulating theories to explain these luminous phenomena. Were they icy spots reflecting sunlight, or perhaps something more extraordinary? Ideas ranged from mineral accumulations to potential signs of icy volcanic eruptions. To many surprise, detailed examination showed that the brightest spot wasn't a single object, but rather a cluster of distinct reflective zones. The prevailing interpretation was that these were salt deposits left after water sublimated. This pointed to the notion that Ceres once had, or may still possess, internal mechanisms capable of transporting water or saline fluid to the surface, where it rapidly evaporates and leaves behind bright crystalline material. Such discoveries challenged earlier assumptions about Ceres, portraying it as far more active and complex than previously thought. The possibility of liquid or briny water beneath the surface holds significant importance in debates about life's feasibility elsewhere in the solar system. Often depicted as a frozen world with a rocky yet porous exterior, Ceres is unlike the largely metallic and stony asteroids. Its surface is a mixture of water, ice, and water-rich minerals such as clay and carbonates, making it less dense than its solid neighbors. This composition indicates Ceres may harbor substantial quantities of water underground. The outer crust is solid but porous, containing frozen water and other volatile elements, making it resemble a comet more than a typical asteroid. It is believed that Ceres has a distinctive internal structure, a rocky shell and a watery, ice-rich core comprising nearly half its volume. Its mantle likely blends rock with salty water surrounding a denser center that may consist of silicates. This abundance of ice supports the hypothesis that liquid water may have existed inside Ceres, especially if its core generated heat through radioactive decay in the past. Such an interior design distinguishes Ceres and raises exciting questions about its possible geological activity and how water influenced its evolution. But there's more. The detection of ammonia-rich clay minerals on Ceres suggests the planet may have originated in the colder outer regions of the solar system before migrating inward. Ammonia can lower water's freezing point, potentially permitting salty fluids to exist nearer the surface. These discoveries about Ceres, past and present, help us understand not only this dwarf planet but also the forces shaping icy objects throughout the solar system. Cryovolcanism is a rare and unique geological phenomenon, especially compared to the more familiar lava eruptions on Earth. Instead of molten rock, ice volcanoes emit substances such as water, ammonia, or methane, which can remain liquid or gaseous under extremely cold conditions. On Ceres, this process allows salty mixtures to ascend to the surface. Once exposed to the vacuum of space, the fluid quickly transitions into gas, a process called sublimation, leaving reflective salt residues that appear as the mysterious glowing patches. The most famous of these is found in Ar Crater, particularly in a zone nicknamed Spot 5. Noted for its intense brightness and temporal changes, these fluctuations are believed to be connected to water evaporation, implying that cryovolcanism may still be occurring or happened recently. Beyond Spot 5, Ceres features numerous other luminous locations, each with distinct characteristics. These are not confined to a single region but scattered throughout the planet, suggesting cryovolcanic activity could be widespread. Their presence indicates that Ceres is still geologically vibrant, challenging previous notions of it as a frozen, dormant body. As dawn continued sending back increasingly refined imagery, it revealed a landscape filled with craters, each narrating part of Ceres's history. These findings transformed how scientists understand the dwarf planet with its icy shell and indications of internal dynamics. Ceres is now regarded as an evolving world, not merely a leftover cosmic remnant. The glowing areas, especially those in AAR, remain a source of fascination. They may signify not only geological forces but also processes that suggest subterranean water. Studying Ceres has broader consequences beyond comprehending one small planet. By analyzing its core structure, unusual surface traits, and shiny deposits, researchers gain insights into the development of other cold planetary bodies. The substances discovered on Ceres, like ice, ammonia-rich minerals, and reflective salts, could help us decode the chemical composition and environmental behavior of similar worlds. Furthermore, the presence of cryovolcanism opens thrilling avenues in planetary science, not only on small bodies like dwarf planets and frozen moons, but potentially even on exoplanets many light-years away. This means areas once believed barren and lifeless might actually support complex natural phenomena. Could it also imply that distant planets, long regarded as icy wastelands, might possess suitable conditions to sustain life? Concluding thoughts on NASA's Dawn mission and its impact on humanity. NASA's Dawn endeavor stands as a brilliant example of what space exploration can accomplish. The data it collected has already reshaped scientific understanding of the formation and transformation of our planetary system. As we continue to investigate Ceres and other remote bodies, each new discovery helps assemble the grand puzzle of how worlds form and evolve. Currently, The glowing zones on Ceres remain among planetary science's greatest mysteries. But they are only the beginning. As technology advances and new missions are launched, the probability of further groundbreaking discoveries increases. Once merely a tiny, overlooked object in the asteroid belt, Ceres now emerges as a beacon of mystery and scientific potential. Its terrain, hidden layers, and shining marks could one day unlock essential insights about the solar system's early epochs and the forces that shaped it. The idea that life, or at least the components for it, might exist on Ceres continues to excite scientists and space enthusiasts worldwide. As we venture further into the cosmos, the boundary between fantasy and reality diminishes. What was once the realm of science fiction, the question of life beyond Earth, is now a serious scientific endeavor. Could microscopic life forms survive in Ceres's concealed reservoirs? Might the environments of other icy worlds support life forms either familiar or entirely new to us? These are the questions that will drive the next wave of space exploration and perhaps, one day, unlock the deeper enigmas of the universe itself.